larger expansion. So if you look on this page, just kind of glance down, what you'll see, right, is we're dealing here with things being raised to the 18th power, and we want the 15th term, or the 17th term and the 30th power. Like, you're not going to use Pascal's triangle to expand something to the 30th power, right? So that's why binomial theorem is helpful. So what they've done is up here, they've just written binomial theorem out with the n choose 0, n choose 1, n choose 2 as our coefficients, right? Those are they'll match up with Pascal's triangle. The a to the n, we've already known that. That was a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, whatever it was. And then the b's are the same. They just start with b to the 0, b to the 1st, b to the 2nd, b to the up until n minus 1 and n, right? So this makes sense. We talk about the rth term, right? Rth term just means which term in this sequence it is, or in this expansion. So like this would be my first term, this would be my second term, this whole thing right here would be my third term, etc., right? Until you get up here, this is your nth term, this one would be my n minus 1th term, okay? So this is r, okay? So where does r come from? Well, how does that correspond? Well, notice the bottom number, right? This is actually first term. Yeah, so it's always 1. This is actually n minus 2. Sorry, I lied. This is the n minus 1th term. No, n plus 1th term. This is the nth term. Okay, so remember when we went through, we always said there was one more term than the exponent. Can you guys hear my son screaming in the background? All right, I'm sorry if you can. He's playing Xbox in the basement with a friend. And he's like screaming, and I have the door closed, but I can still hear him. So I'm sorry if you hear him screaming. Okay, so we said the number of terms is always one more than the exponent, right? So if there's n exponents, that means this is n plus 1th term, and this is the nth term right here, okay? So the correspondence is that this bottom number is always 1 less than r, right? So that bottom number is always r minus 1. The top number is just always n, no matter what, okay? The exponent for a, if you look at it, is always n minus r minus 1. What does that mean? It's this, the top minus the bottom. That's what I like to call this, top minus bottom. So I take n minus this number, n minus 0, that gives me n. That's the exponent. N minus 1, oh, look at that, n minus 1. N minus 2, oh, there it is. N minus 1. That's right, n minus, what would that be? N minus 1. Well, that becomes a positive 1, so that's the exponent for a. And n minus n is 0, so it was a to the 0, okay? Similarly, the exponent for b is always just whatever number was on the bottom. Okay, so what does all that mean? All of that means that the rth term, wherever it is, third term, fourth term, fifth term, rth term, is just going to be n, choose r minus 1, over a to the n minus r minus 1, b to the r minus 1. Okay, so this is our formula. Now, normally I would say memorize that, but since if we have any exams on this stuff, it's all going to be open note anyways. I'm not going to tell you to memorize it. You're just going to look it up. So know where it is and know how to find it, and then know how to use it. So here we go with an example. So it wants us to find the 15th term. That is r. Okay? Let's define our other variables. This whole thing is a. This whole thing is b. And this right here is my exponent, so that was n. Okay? So the 15th term is n, choose r minus 1. So let's go through and do it. So n is just 18. R was 15, so it's n, choose r minus 1. And then it's a, which was x squared, raised to the n minus r minus 1. Well, n is 18 minus the quantity r minus 1, which was 15 minus 1. B, and now you can, there's different ways of thought. You could keep the negative in here with it, and I'll go ahead and show you that way. The other way would be to attach a negative 1 times it, and then they both be raised to that. But I'm going to go ahead and keep the negative with it. The other way is to think about the alternating that we talked about with Pascal's triangle, and then decide in that sequence, if it's alternating, would that 15th term be positive or negative? And think through it that way. So either way, I'll go ahead and keep the negative in here. So we're raising this to the r minus 1. So it would be 15 minus 1. All right, so let's work this out. So this is 18 choose 14. And then this is x squares raised to the, well, this is 14. So 18 minus 14 is 4. And 15 minus 1 is 14. All right, so I'm going to use my calculator to do 18 choose 14. So I still have it up there. I can just go with that and change it to 18, choose 14, 3,060. And then power to a power you multiply. And then negative to the 14th would become positive. So this would just be 1 over x to the 14th. So this is 3060 x to the 8th over x to the 14th, but we know that can simplify, so I'd be left with 3060 over x to the 6th. And that's it. That's my 15th term of that expansion. So if I were to expand that whole thing out all the way to 18, 19 terms, the 15th term would be that one right there. Okay, let's try another one. 17th term. Okay, so defining variables here. This is r, this is n, here's my a, and here's my b. All right, so n choose r minus 1. So n is 30, r minus 1, 17 minus 1. Quantity 2x squared, it's that whole thing is a, and that's raised to, and I always do top minus bottom. So if you think about this, this is going to be 30, 16, so top minus bottom, so 30 minus 16 would be 14. So you can kind of skip some steps once you're getting used to this. And this is always whatever the bottom one was. Right, that's r minus 1, so it's just bottom. So this I do top minus bottom, here I do bottom. This distributes in, so this is 2 to the 14th, x to the 28th, y to the 32nd. Okay, 32, 16. 30 to 16. Whoa, that's a big number. 1, 4, 5, 4, 2, 2, 6, 7, 5. But then I have to do 2 to the 14th. So 2 to the 14th is another big number. 16, 3, 84. And I have to multiply those two together. And I get, ooh, scientific notation, 2.38 times 10 to the 12th, because that's going to be a very big number. So here you see that e on the calculator. That just means scientific notation times 10 to the 12th power. Okay, x to the 28th, y to the 32nd. Yeah, I wouldn't have wanted to do that one using Pascal's triangle. So 30 terms, right? We're finding the 17th term. That's what it would look like. Okay. Last example, find the 8th term. Okay, so that is r, here is n, a is just a in this case, and b is that whole thing. Okay, I'm going to go through this. It might be easier to switch this radical to an exponent. Let's rewrite the square root as raised to the 1/2 power. I think that might be easier. So I'm going to do n choose r minus 1, right? So it's 10. R minus 1 is 8 minus 1, so this becomes 10 choose 7. A to the top minus bottom, so 10 minus 7 is 3. My b term, again, is the square root of 2a, and that's raised to the bottom, which is 7. So let's think about this. I'm going to rewrite this as 2a to the 1/2, and then take that whole thing and raise it to the 7th. So then power to a power means I multiply. So this becomes 2a to the 3.5 or 7/2, right? A to the 3rd, 10 choose 7. That's not too bad to figure out on our calculator. 10 choose 7, 120. So 120. Okay, so this 3.5, what's happening there? Right, so let's keep going. I've got 120 times 2 to the 3.5, a to the 3rd, a to the 3.5. So 2 to the 3.5 Let's try it. Okay, so that's kind of weird, right? And it doesn't look very exact to me. So let's not do that. Let's go back to 7/2. Okay, right? Let's think about it that way. Here, when you multiply, you add. So that would become 6.5, which again, I don't want a decimal exponent. That's kind of weird. So that's the same thing as 13/2. So if I think about that, you could leave it as 13/2, or you could do square root of a to the 13th, right? Rewriting it in that way. And so that would be square root of a to the 13th. What would that be? A to the 6th, and then square root of a, right? If we simplified that even further. All right, so then here, 2 to the 7/2, again, same idea, would be square root of 2 to the 7th. So what would that be? 2 to the 3rd times root 2. We still have this 120 out here. Next, there'd be 7 of those, which would give me 3 groups. Yeah, so 2 to the 3rd is 8. 8 times 120 is 960. Radical 2. And then we've got this idea here. So final answer, 960 radical 2, a to the 6th radical a. Woo, that was ugly. All right, so hopefully you followed along with that. That was a tricky one at the end there. But this is what you'll be practicing. Homework tonight is, well, I guess this is all homework. Ha, ha, ha. But your assignment to practice will be the next 2 pages in your practice packet, so pages 3 and 4, just practicing with binomial theorem. Use your calculators, double check your answers, and then submit them to me on Schoology. Have a great day, you guys. Bye.